All right, guys. So we are going to do exam 8 tonight. Your test is tomorrow. It is open from 9 a.m. to 9 p.m. If you are here from another teacher and you need credit for that class, just throw your name in the chat and what teacher, and I will make sure I let them know that you were here. All right, let's get this party started. All right, so we're doing polynomials this time around. And I feel like these concepts individually are easy, but when they get all mixed together on the test, you guys make some simple mistakes. So let's go through these one by one. And let's just remember, and I'm not trying to speak to you like you're dumb or anything, but remember our operations, okay? So this right here is subtraction. Okay, don't start multiplying things out. These guys here, multiplication. They're right next to each other. Addition, okay? Multiplication and then subtraction. So really important that you look at the operation and that you don't, get ahead of yourselves or just start overthinking, and that you're good to go. So when we're subtracting, the most important thing with subtracting is that you distribute this negative to whichever polynomial is behind it. So it basically is going to change all the signs of this polynomial. So we're going to distribute that all the way across. This guy right here is going to stay the same. So it's going to be 3x squared minus 4 minus 2 plus x minus x squared. Okay, I just change all the signs up there. And then we just need to combine like terms. So I have a positive 3x squared and I have a negative x squared. That's going to give me 2x squared. I have this x all by himself, so he goes next. And then the last thing I have is a -4 and a -2, which is going to get me -6. So that one's super easy, straightforward, subtracting, no problem. For this one, I'm going to show you guys the most common mistake with this problem right here. The most common mistake with this problem is the answer is going to look like this: x squared plus 36, because you took that 2 and you went there and you went there. Okay, and then you got x squared plus 36. And that is wrong, my friends. Do not do that. Don't do that. Okay, 100% that'll be on the test tomorrow, because this is one of the most common mistakes we see in Algebra 1. So what this says is x minus 6 times x minus 6. Right? And then you've been given 3 ways to try and solve these problems. You've been given the Punnett square, the vertical, or the FOIL method. And when you're given problems like this, it doesn't matter which way you want to go about it. So you can pick and choose your method unless it specifically says do it this way, or you're given a box and you're like, hey, I have to do it that way. So for this one, I'll just FOIL it out for you guys. Fans going super crazy here. Okay, so let's just FOIL this out. I go first, which gives me x squared. So that's the f first, outside. The outside ones gets me -6x. The inside ones gets me -6x. And then the last ones get me positive 36. And then, of course, you don't leave your answer like that. You combine your like terms where you can right there. So this guy is going to be x squared minus 12x plus 36. By doing it this way, the incorrect way in the beginning, that's the problem, because you're losing your middle term. Okay, so you want to make sure you don't do that. And I feel like this pen is kind of reflecting. So let me grab another pen. Oh, look at that. It's the Descendants. Very exciting. All right, let's do this one. I'm not going to FOIL this one. I'll do this one vertical method so you guys can kind of see all around. We have x minus 6, x plus 6 for this one. We're multiplying again. And -6 times 6 is -36. 6 times x, 6x. Nothing goes there. Remember, this is the same as you guys learn how to multiply double digits back in the day in like 4th grade. X times -6, -6x. X times x, x squared. And then there we go. We've got x squared. That guy goes away. Minus 36. And there's your answer. Okay, so just careful with these, especially this one. careful with your signs. Don't get caught up in that, and take your time. All right, let's do this guy right here. 4x minus 3 times 3x plus 4. And because we did a FOIL and a vertical, I'll do this one in the Punnett square so you guys can see this one. Depending on how you guys like this. Again, when you're doing this on your own and it doesn't tell you which one to use, whichever way you're comfortable with. But for tomorrow's exam, you will need to know how to do all three, because there's going to be certain problems where it's going to say, if you were to FOIL this, what would the first term be, or stuff like that kind of stuff. So for these guys, it doesn't matter which one goes here, which one goes here. Just make sure you're consistent. So I'm going to put my 4x minus 3 there, and I'm going to put my 3x plus 4 here. And then you're just going to multiply. Make sure all your boxes are filled. So I really like this method when you're dealing with, when you have to multiply trinomials, because then you're always going to make sure you're not going to miss one. And I think that's really important, that you don't miss any. So when we're here with this one, I've got 3x times 4x, which gets me 12x squared. 3x times negative 3, negative 9x. 4 times 4x, 16x. And 4 times negative 3 is negative 12. And then I can just combine my like terms and see what I got. So I've got this guy here, 12x squared. He's first. I've got these two guys right here, which gets me positive 7x. And then I've got my last guy right here, which is negative 12. And there you go. So that one's no problem. Okay. This guy right here, you are adding. So adding's always a little bit easier. When you add, you can just drop the parentheses and combine like terms. So I've got y cubed minus 4y plus 1, and then plus 2 minus y plus 3y squared. So if I look for my highest exponent, I've got this guy by himself. So I've got y cubed. And my next highest exponent is right here, plus 3y squared. And then I've got negative 4y and negative y, which give me negative 5y. Remember, when you're adding and subtracting, you don't change the variable, you don't change the exponents, you just combine like terms. When you're multiplying is when you gotta switch up the exponents. And then right here, I've got plus 3. Plus 3. So there you go for that guy. Okay. And then this one right here, let me zoom in a little bit. Maybe I'll make that easier for you guys. Wow. Okay. So for this one right here, you have to do the multiplication first. So do this guy first. And so for this one, I'll FOIL it out. I've got 2x squared. And then I've got plus 6x inside minus x outside minus 3. So here's this one right here FOILed out. I've got 2x squared plus 5x minus 3. And then this one right here, don't forget to distribute your negative. So that gives me minus 4x, minus 4x squared, minus 3x. So minus 4x squared, minus 3x. I just brought it down. I didn't do those till the end. Okay. And now you can take a look at this and combine like terms. So I've got negative 4x squared and positive 2x squared, which gives me negative 2x squared. Remember, you're only dealing with the coefficients here. And then we've got a positive 5x and a negative 3x, which give me positive 2x. And then I've got my constant, and he's hanging out right here by himself, negative 3. Okay, so there's some of each. All right. Find the degree, the leading coefficient, and the constant. Okay, so the degree is the highest exponent. Okay, that's the highest exponent. The leading coefficient is the number in front of the term with the highest exponents. Right? So once you locate which term has the highest degree, whatever number is in front of those exponents, that's your leading coefficient. And then your constant is always the number without a variable. Okay? So if you don't have a number without the variable, your constant will be 0. And I think I have an example like that here. Okay, so first things first. These are not in standard form. If it's in standard form, it's going to go from the highest exponent to the lowest exponent. So you need to make sure when you're looking at these that you just don't think that the first one there is always the first term. The first term in standard form is always the one with the highest exponent. So in this case, it's going to be this. It's going to be negative 4x cubed. That makes my degree for this one 3. My leading coefficient, the number in front of the term with the highest exponent, is right here. So my leading coefficient is negative 4. And my constant is the number without a variable, which is right there. So my constant is 1. All right. This guy here, you have multiple variables. What do? Well, you got to add up the exponents. So you can't just tell by saying, oh, this one has an 8, a 5. You can't do it that way. It's got to be the one that adds up to be the highest. So if I add these up, this guy has 6. This guy has 5. This guy has 12. So there is my term with the highest number. Okay, the most amount of the highest degree. Okay, so my degree is 12. My leading coefficient, the number in front of that, negative 3. And my constant, there is nothing here without a variable, so my constant will be 0. Okay, and the last one on this page, we've got a negative x cubed plus x to the 5th minus 1. Well, there's the winner right there at 5. So my degree is 5. My leading coefficient, what's in front of this 5? Well, there is a positive 1 right there. So my leading coefficient is 1. And my constant is the guy without the variable, and he is negative 1. All right. So far, so good. Moving on. All right, let me just make sure I have you guys down here so that I'm just going to write your names down real quick. Make sure you guys are good. And I know that Factor's good because she's going to Harvard, so this should be easy for her. All right, let's do this. We're going to fill in the next terms. I'm going to put my sunglasses there because my fan seems to be blowing at high speed right now. Okay, so fill in the next terms of the sequence. Remember, we have 2 types of sequences that we learned. We learned arithmetic and geometric. Where arithmetic are the ones that you add and subtract. Geometric were divide and multiply. So to get from 3 to negative 2, how did I get there? I couldn't have multiplied anything. I could have gotten from 3 to negative 2 by subtracting 5. And then how did I get from 2 to negative 2 to negative 7? Well, I subtracted 5 again. So I can see my pattern, and I'm going to subtract 5 again. That's going to give me negative 12. Subtract 5 again, negative 17. Subtract 5 again, negative 22. Okay, that is arithmetic because I'm adding or subtracting. This guy right here, you have, I got from 4 to 12. So I could have said I added 8, or I couldn't have added 8 because that's a negative 4. So I multiplied by 3, but if I multiplied by 3, that would have gotten me a negative 12. So I multiplied by a negative 3. Okay, so I multiplied by a negative 3. Negative 4 times negative 3 is positive 12. Positive 12 times negative 3 is negative 36. And then here we go. Negative 36 times negative 3 is going to get me positive 108. Positive 108 times negative 3 is going to get me, is that 24? Negative 324. And then negative 324 times negative 3 is going to get me, is that 12, 6, 7, positive 972. So you're just multiplying around. Okay, this one is geometric. All right. Okay, these guys right here, you are moving from exponential to radical or from radical to exponential. So this one is in radical form. I know that because there is a radical in it. And so this one is going to look like x to the 1/5 power. And remember, the denominator is what's on the outside. The numerator is what number goes in here for the exponent. This guy's in exponential. I want to put him in radical. So make sure there's a radical in your answer. And when you have that, you're going to have the cubed root of x to the first. Okay? If you don't put the 1 in there, that's okay. No big deal. Okay, this guy right here, it's in radical form. We know that because there's a radical there. So this guy here is x to the 2/3 power. And then this guy here, we're going to put him in radical form. All right, so remember the denominator always comes out to the front. 6 to the x cubed, or 6 rad, 6 rad x cubed. And then, I mean, if you wanted to reduce this before, you could have reduced that beforehand too. So that's fine. Okay, simplify using all 3 methods. So I have the same binomials that I'm multiplying, and I'm just going to show you guys how to do it very quickly, multiplying it all 3 ways so you are prepared for your test tomorrow. And remember, on an exam like this, especially when we're having you do things 3 methods, it's not always about the answer. Okay, obviously you're going to get we don't want you to get the same answer 3 times. We want to know that you know when to use what and how to do those. So I'm going to use foiling first. So foiling, I multiply my first terms. That gives me 24x squared. I do my outside terms. Okay, so 6x times 2, which gets me 12x. My inside terms, that's the I right there, minus 20x. And my last terms, -5 times 2 is -10. Combine your like terms right here. And I have 24x squared minus 8x minus 10. Okay? Hopefully we get the same thing for the other 2. Otherwise, I screwed up somewhere. Let's see. Let's do the square. I'll put it up right here. Okay, so in the square, I've got 6x and -5 and 4x and 2. Again, multiply, make sure all your squares are filled. Obviously not this guy right here. Hopefully you guys are good at this from bio. This is 24x squared minus 20x. I've got 12x right there. And I've got -10. Well, I'm already looking pretty good because I can match these up and see that I got the same factors for everything, or the same terms for everything when I multiplied them. So let's put them all together. I've got 24x squared. These guys right here, -20, +12, minus 8x. And this guy right here, minus 10. Okay, so there's your Punnett square. And last one is vertical. 6x minus 5. Actually, I'm going to put the 4x plus 2 on there just so I don't run out of room. Okay. Be nice if I could read my own writing. There we go. So -5 times 2, -10. Whew, already looking good. -5 times 4x, -20x. Cool. At least I know I'm getting the right answer. Don't forget to put in your placeholder. 6x times +2 is 12x, and 6x times 4x is 24x squared. Add them up. There you go. 24x squared minus 8x minus 10. Okay. 3 methods. Make sure you guys are comfortable with all 3 methods, okay? Especially when we ask you to do things like error analysis, or if you have to fill in the chart, or if, we give you part of this, but then we're saying, okay, what number should go here? Make sure you guys are comfortable with all 3 parts, or all 3 ways of doing this. Okay. Last page. Let's get her done. This way. Okay, let's do this. Let's do the absolute value equation. Okay, so this was review from last exam, and I heard you guys did really well, so that's great overall. There are a couple ways to go about this. To find an x-intercept, we always do the same thing. So to find x-intercepts, you make y equal to 0 and then solve. So in this case, g of x is just a fancy way of saying y. So I'm going to plug in 0 is equal to the absolute value of x plus 2 minus 1. Now, if you remember from last week, you need to get the absolute value by itself. So I got to get this guy over here. I'm going to add 1 to both sides. And I get 1 is equal to the absolute value of x plus 2. Now that the absolute value is by itself, break it up into two equations. So I have x plus 2 equals 1, x plus 2 equals negative 1, and solve. X equals negative 1, and subtract 2, getting ahead of myself, x equals negative 3. Okay, so x equals negative 1, x equals negative 3. On your graph, x equals negative 1, x equals negative 3. There you go. Graph them, your x-intercepts. Y-intercept. To find a y-intercept, you make x equal to 0, and then you solve. So in this, it's y equals the absolute value of 0 plus 2 minus 1. Y equals the absolute value of 2 minus 1. The absolute value of 2 is just 2. So y equals 2 minus 1, which gets me, no worries, you're all good, which gets me 0. Oh, does not get me 0, which gets me 1. Oh my goodness, I got distracted. Okay, so don't worry, whoever ER is. You're all good. It's being videotaped. You can come back. You can watch it again. I don't know why you'd want to, though. All right, so there's 1. My y-intercept's at 1. Okay. Vertex. Vertex is always a fun thing to see here. Vertex, vertex. You can see the vertex up here. This is actually called vertex form. And they do that because you can find the vertex very easily. So remember, the vertex is always the opposite of whatever number is in here. And then this number as is. Okay. All right, so the opposite of this number is negative 2. This number as is negative 1. And we can plot that at negative 2, negative 1, right here. So a lot of you guys on your test, you guys just put these little dots here and didn't connect them. Okay, you got to connect the dots. All right, you have to connect the dots. And I know it's a little tricky on your mouse pad when you're trying to do all that, but absolute value graphs look like a V for Verdugo. So you come down here, and absolute value graphs, they go on forever like this. Right? Okay. So one thing, because you guys are on here, I'm going to give you a little pro tip for tomorrow's test. When you look at a graph, okay, when you look at a graph and you look at this equation, I'm going to write the equation right here. I'm going to write the absolute value of, let's go, what is it, x plus 2 minus 1. Okay, there's my graph right there. Okay. When you look at this graph, you can't just assume that this graph is going to work out just because of the vertex. So when you guys get problems like this, and I know there was one on your last test where like, which ones are true? Okay. And you had to check, is the x-axis, is the x-intercept good? Is the y-intercept good? Is the vertex good? Okay. Does this equation work? You can't just look at the vertex and say, oh yeah, it's cool, it works. You have to look at other things also. All right, so make sure you guys go and say, okay, wait, I don't know if this graph works. Yeah, the vertex is cool, but maybe the y-intercept doesn't work. And when you're doing an absolute value graph, let me zoom out so you guys can kind of see all of this in one. When you're doing an absolute value graph, the vertex is obviously the easiest thing to see. The y-intercept is the second easiest thing to do. So at least, start going through and spot checking to make sure that those things work before you select one for the graph. All right. Hi, guys. Thanks for checking in. I'll let your teachers know that you guys are here so that you guys get your points or whatever it is I promised you. I don't know. Okay, so that's that on absolute value graphs. Make sure you guys connect the dots. If there's a graphing one on there tomorrow, you need to connect the dots. And make sure that, oh, the other thing that a lot of people missed last week is when they had to say, you know, is it right or whatever, check the ones that are right. Let me zoom in again so you guys can see this. Okay, my x-intercepts are -1, 0 and -3, 0. My y-intercept is 0, 1. Okay, that's how you write you guys already know this. But a lot of people missed this on their test last week because they wrote their y-intercept as 1, 0. And you guys are like, oh yeah, I got 1. That one's cool. That does not say that your y-intercept is 1, 0. That says your x, that's saying that the x is 1 and the y is 0. So make sure you guys don't fall for that little trick if it's there on the test tomorrow, because that, I can see you guys getting tripped up on that. Don't fall for those little tricks. Not fun. Okay. Last problem. And then if you have any questions, I will be more than happy to go over extra problems, or if you have a certain type of problem you want me to do, I'll find it, you know, I can find something, I can make something up and we'll go over them, whatever you guys want to do. So last one. All right, my solutions can be -1, -2, or 3. And then these kind of things, you just have to go with what you're comfortable with. Okay, this really comes down to what are you comfortable with. And this is a +1 right there, by the way. So for this first one, I'm the most comfortable just solving it because it's just a basic equation. All right, I get -3x equals -9. Divide both sides by -3. X equals 3. Cool. There's my solution. If you don't like that, you can always just plug in everything and see if it works out. Okay, and what's great about problems like this is that there's always like the long way to do it. Now, the long way to do it, you don't want to get stuck because you only have an hour to take your test. So you got to make sure that you're being efficient. But remember, there's more than one way to do this. Okay, this guy right here, you got an exponential. 4 to the x plus 1 equals 1/4. And you're like, oh, crap, I don't remember how to move this. I don't know how to make the bases the same. I don't remember any of that. Well, you could just maybe plug in some numbers and see what you get. So let's do that. Let me plug in 3. If I have 4 to the 3 plus 1, that gives me 4 to the 4th power. That's 4 times 4 times 4 times 4. That is definitely not 1/4. So that one's not going to work. Okay. If I had 4 to the -2 plus 1, that gets me 4 to the -1 power. Wait, maybe that is. That's 1/4 equals 1/4. So that guy's cool. So -2 works. Okay. -2 works for this guy. And if I plug in -1, I have 4 to the -1 plus 1, which gets me 4 to the 0, which just equals 1. Okay. So careful with these. The other way to do this is if you remember how to do it, you could just solve it. That when you're doing this, I'm going to write it down here. 4 to the x plus 1 equals 1/4. This is 4 to the x plus 1 equals 4 to the -1 power. Okay, that's how you rewrite that. 4 to the -1 is 1/4. And when you have the same base, you can set your exponents equal to each other. So x plus 1 equals -1. Subtract, and x equals -2. So yes, I got this quicker this way, but that's because I remembered how to shift this around and how to put this and get the same base. If you don't, plug in numbers and see what makes sense. Okay, this guy here, this should scream, hey, probably going to get 2 answers. Probably going to get 2 answers. So let's do that. The absolute value is already by itself. 2x plus 3 equals 1. 2x plus 3 equals -1. You don't want to set up the equations? Plug in all the numbers and see if they work. Subtract 3. 2x is equal to -2. X is equal to -1. So there's one of my solutions. That's good. He's up there. There's -1 up there. Let's do the second one. Subtract 3 to both sides. 2x is equal to -4. Divide both sides by 2. X is equal to -2. That was one of my other solutions. So my solutions are -2 and -1. Okay. And then this guy right here, he's a tricky one. This little negative here kind of makes it fun. All right. Anything to the 0 power is 1. I think you guys are good with that. But remember that that little 0 right there only impacts the 2. Okay? It doesn't impact this negative. So 2 to the 0 power is 1, but that negative still stays out there. So that's like negative 1 there. And then that's equal to x over 2. What number can I put in there? Well, my choices are x equals negative 1, negative 2, or positive 3. And I can easily tell that the only one that's going to work is negative 2. Okay, if I put negative 1 up there, I'm going to get negative 1/2 equals 1. No, it does not. Negative 2 will get me negative 1 equals negative 2 over 2. So that guy's good. Okay? All right. That is that for tomorrow. Polynomials. Your exam opens at 9 a.m. Oh, you know what? Sorry, I forgot to do one down here. I forgot this little guy. Okay. Is g of 10 equals 11 on the graph? Show work. All right. So what this says is when x is equal to 10, does y equal 11? When x is equal to 10, does y equal 11? All right, that's what this wants to know. So let's just see. We have g of x equals the absolute value of x plus 2 minus 1. Let's plug it in. They want x equal to 10. Okay, so remember this is y. That's y. There's x. Okay, they want when x is 10, does y equal 11? Let's see. You know y needs to equal 11. Equals the absolute value of 10 plus 2 minus 1. We've got the absolute value of 12 minus 1. 12 minus 1 is 11. And 11. So, yeah, it's on the graph. It's all good. Okay. That's all I got for you. Unless you have something in the chat that you want me to do, I will be more than happy to make up another problem and let you know and do it for you. Again, for those of you that kind of got here late, it's all recorded. So as soon as I end this, it'll pop up on my YouTube for you to watch again, and then you can, do what you got to do. But we went over subtracting and adding. We went over multiplication, and we multiplied, and this is a total mess, in vertical, FOIL, and Punnett square. Okay, we did this little challenging one down here where you had to multiply first and then subtract. So make sure you guys are good with that. We found degrees, leading coefficients, and constants. Okay, we did a little bit of review on arithmetic and geometric sequences. We went back and forth between exponential and radical form. I solved the same multiplication of binomials in 3 different ways, just for practice to make sure you guys could do all 3. We did a review on absolute value and just did some little solving things that you guys are going to see on your test. Okay, so if you don't need anything, then I'm going to end it. Otherwise, you have a couple seconds or so to get something in the chat. All right, good luck tomorrow. Again, your exam opens at 9 a.m. and I will let your teachers know that you guys were here. I just want to make sure I got everybody from Mr. David's class, Mr. Chung's class, and Mr. Nakauchi's class. Sounds good. Okay, I will, oh wait, I missed somebody. Okay, Ethan and Nakauchi. Have a good night, guys. Good luck tomorrow.